So problems A, number
3.
We have 3 teams playing tug of war on a circular rope. Team A is pulling east at 500. Team B is pulling due north with 250. And Team C is pulling straight west with 750. And we want to know what's the resultant and who is winning. Now, this was the first problem I gave you that had 3 things to it. And so some of you freaked out over that because it's like, I don't know how to add 3 numbers, I just know how to do 2. Well, all you got to do is add 2 numbers and then add the third one to the second answers, and that would be it. But if I add these 2 together first, then I'm going to get some weird thing going off here, and I don't know how to add that to this. Or if I add these together, I'm going to have some weird thing going here, and I don't know how to add that together. So the smart thing to do is say, is there an easy way to add these up? And there is an easy way to add these up, because if I look at these 2 are super simple to add up. Who's going to win?
750.
The 750. By how much?
250.
In what direction?
West.
So this 250 just took care of those 2, right? So now I still need to add the third one, and the third one is?
250.
So where this one stops, this one begins, so that way it's head to tailed. And then I draw this and call it R. And then, of course, if I Pythagorize that, I get 353.6. Is that right?
53. Yeah. 30.
I don't know, somewhere in there.
Got it. That's it.
Yeah, what a memory. Okay, and then I need an angle. And so, of course, to find the angle, I have to look at this angle. And I say, well, this is opposite and this is adjacent. But, of course, those of you who are astute with your math say, hey, look, if this side and this side are the same size, then that only works when I have a 45 triangle. So this must be 45, which means this one is 45 away from this one, which is pointing straight
West.
which is 270 degrees. So is that 45 bigger or 45 smaller?
Bigger.
That's going toward 360, so it's getting bigger. So 270 plus 45 gives me 315 is where this puppy's pointing. So we're going to write in 315. Yay! Now, some of you had trouble with number 5 also, because you're wusses. So, in number 5, we had a river, and the river was flowing. Well, this is number 4, but it ties into number 5. So, it was flowing downstream at 15.5.
Yes.
Is that right? So, it was going south at 15.5 meters per second, and we had Vivian traveling in a boat. Woo! So there's Vivian in her little boat, and she's going west at 32.5 meters per second. So 32.5 meters per second. Now, in number 4, we had to find the resultant velocity of the boat because, of course, she couldn't just go straight across the river because the water's pulling her downstream. So she ended up going this way, right?
Yes, Paulson.
Yes, sir.
This is do you have a Karime Ortiz?
Yes.
Can you take it to the turn office for a couple of minutes to the turn office, please?
Sure.
Thank you.
So this turned out to be 36 meters per second when we did that. Now, in number 5, what we asked was if the river is 190 meters wide, how long did it take for the boat to go across the river? And then how far downstream was it at that time? So first thing we got to look at is we say, hey, here I have a velocity, and here I have a displacement, and I'm looking for a time. Do I have a nice formula that goes with those? And of course you should say, yeah, I know that V equals D over T, so if I'm looking for T, these two are going to trade places. And so I'm going to end up with T equals D over V. So the D is clearly going to be 190 ohms. The question is, which V do I use? Because I have 3 different V's. I've got a V that's going this way, I've got a V that's going this way, I got a V that's going this way. Which V is going to be the right one to use?
The roads.
Now, here's where it gets, where you have to think a little bit. What direction is the 190 going? Straight across. So which velocity matches that? The one that's going straight across, which would be what? The 32.5. These two are going the same right across from it. And now I realize some of you were saying, but wait a minute, Paulson. It may have, these may go together nicely, but in reality the boat was actually traveling at 36. So shouldn't I use the 36? I should use the 36, but in reality, it didn't travel 190 meters either. It traveled at some angular distance, which would have been a bigger duh. So what I'd have to do is make a new triangle and say, okay, the angle that I figured out in problem 4, I stick it here, and I stick the 190 here, and then I solve for this distance, and then I put that distance up here, and then I put the 36 down here, and guess what? It would come up to the exact same answer with a whole lot less work that I got doing that. So all I have to do is say, hey, the distance is going straight sideways, so the velocity that's going straight sideways is the one that matches it. And so we make that work. So if I take this divided by that, I get 5.9 seconds. And in that 5.9 seconds, of course, it has been pulled downstream by the current. So then I say, well, how far downstream did it go? Well, in this case, the D is going to stay there, the T is going to come up. So D is going to equal TV. So the T is still going to be that 5.9 seconds. But this time, which velocity do I want to use? If I'm figuring out how far downstream. What's my, yeah, my downstream velocity is the 15.5. So I just use that. And I get 91 smooths. And that's it. Yay, team.